Okay, so this is problem 411 from your textbook, and we have a ball or a sphere cylinder resting on two inclined planes. Okay, so the two inclined planes are at a 40-degree angle and a 30-degree angle, and we know that the cylinder has a weight of 100 pounds. And we want to find the reaction forces on the surfaces. Okay, so here's the free body diagram. We have the weight acting down. Okay. We have a reaction force on that side we're going to call RA. And we have a reaction force on the other side we're going to call RB. Now those are at angles that are equal to the angle of the inclined plane, but that angle is from the y-axis. Alright? Remember, the y-axis, the angle from the y-axis is not usually the angle that we want to deal with. Okay, so that means that the angle from the x-axis for RB is 60 degrees and for RA is 50 degrees. So now we start writing the equations. Remember, we have two methods we're using right now. The sum of the forces x is equal to 0 and the sum of the forces y is equal to 0. So what has x components? RA has an x component and RB has an x component. So we say RAX minus RBX. Now RA, we said, had a positive x component, and so we wrote it as a positive. So we end up with 0 equals RA times cosine 50 minus RB times cosine 60 degrees. Alright, so we have one equation and two unknowns, so we need to somehow solve for one of the variables. So let's go ahead and solve this. So I'll rearrange it to get RB times cosine 60 degrees is equal to RA times cosine of 50 degrees. Now I can choose to solve for either one of the variables at this point. Doesn't really matter which one. So let's solve for RB. Now, so we'll have to divide both sides by the cosine of 60 degrees, and then we'll end up with RB is equal to RA times the cosine of 50 degrees divided by the cosine of 60 degrees. Okay, so when we do that, we get RB is equal to 1.286 times RA. Alright, so now I need to go ahead and write my next equation, and that's going to be the sum of the forces in the y direction. So we write the sum of the forces y is equal to 0, and what are our y direction forces? Alright, we have RAY in a positive direction. We have negative 100 in acting down, that's the weight of the cylinder, and we have RBY also acting in a positive direction. So when we rewrite that, we get 0 is equal to, well, actually we can just do that as 100 pounds is equal to RA times the sine of 50 degrees plus RB times the sine of 30 degrees. Oh, I said 30, I meant 60, sorry. Okay, so now we need to take RB and substitute it back into this equation. right? So I put a star by it there, and you can see it highlighted, right? And I'm going to plug it in for RB right here. So now we have 100 pounds is equal to RA times the sine of 50 degrees plus, and put in parentheses, 1.286 times RA times the sine of 60 degrees. So now we have 100 pounds is equal to, do some math on our calculators here, 0.7660 RA plus 1.113 RA. So that's when I take 1.286 and multiply it times sine 60. So now I add those things up, and I get 100 pounds is equal to 1.879 RA. Now to get RA by itself, I need to divide both sides by 1.879. And for my final answer, I get RA is equal to 53.2 pounds. Alright, so now I know one of the things I was looking for, but I need to find the other piece. So I'm going to go back to the equation I had for RB earlier and plug that RA in. Alright, and it's the one I highlighted earlier. RB is equal to 1.286 RA. So RB is going to be equal to 1.286 times RA, and when I plug that all in, okay, I'm going to get 1.286 times 53.2. So I find that RB is equal to 68.4 pounds. So those are our two final answers.